Ukmt IMC 2019 from number 11. Let's start. So number 11, which of the following is equal to 3 to the power of 9 and 9 to the power of 3? So 3 and 9 is like a family. So 3 is a 3 because the 3 is the prime number, but 9 is the square of 3. So square of 3 of the power of 3. So square of the 3 number power to the 9 and 3 power to the 6. So 3, 9 minus 6. So 3 power of 3, 27. Rorim 2 played on 4x4 board. So it starts from there. Each turn, reflection of its current cell, a 6-dashed line. How many cells could the counter occupy after? Okay, 3 turns. So this is like reflection. So for example, this can be reflected here or here with this line, and with this line here or here. So it cannot move the third line. Actually, there's no place to go with this third line. Even it starts from anywhere here, it cannot go somewhere. So the reflection can be happened with adjacent lines like this or one apart like this. So in this case, the first case can go just one counter moved, but if we reflect from here, like over this line, then it goes here. So which means when this, how do I call this? When this counter moves, it can go 1 unit or 3 units. So let's start. Let's combine the 1 or 3 together 3 times. So for example, if it moves 1, 1, 1, or 1, 1, 3, or 1, 3, 3, or 1, 3, 1, or 3, 1, 1, 3, 1, 3, 3, 3, 1, 3, 3, 3. So this is how it can move. So let's say 1, 1, 1, 1, 1, 1. It can go here. 1, 1, 1. It can go here. Or 1, 1, 1. It can come back. 1, 1, 1. Come back. Or 1, 1, 1. It's the same. So 1, 1, 1 can be here. And the next one can be 1, 1, 3. So for example, 1, 1, 3. Let's say 1, 1, 3. And 1, 1, 3. This is at this moment, I think we found all the places on the like this borderline, so we don't need to come back on there. So here, and 1, 3, 3. So 1, 3, 3. Oh, okay. We cannot go further with 1, 3, 3. So actually 1, 3, 3 doesn't make we don't need to find further because we already found all. And 1, 3, 1. For example, 1, 3, 1. Let's say here. 1, 3, 1. Let's say here. And 3, 1, 1. 3, 1, 1. 3, 1, 1. 3, 1, 1 is all already we found. And 1, 3, 1. 1, 3, yeah, all 1. And 1, 3, all 1. So it also nothing new. And 3, 1, 3. 3, 1, 3. Let's say 3, 1, 3. Oh, okay. So this also has nothing new. And 3, 3, 1. 3, 3 1, okay, or 3 3 1, okay. So this also nothing new. 3 3 3 3 3 3, or come back. So this also nothing new. So all those I mean, when I says nothing new, it means already we found the position, so we don't need to shade it again. So 1 2 3 4 5 6 7 8. So I think this 8 can be occupied. We can write down a list of 5 numbers. Mean of our first 3 numbers is negative 3. Our first 4 numbers is 4. And our first 5 numbers is negative 5. So difference between fourth number and her fifth number. Okay. So x, y, z, a, b, let's say. So x plus y plus z over 3 is negative 3. So sum of these 3 numbers is negative 9. Sum of this 4 number is 4 by 4, 16. Sum of this 5 number, negative 5 times 5, negative 25. So maybe this number is 25. And this number is negative 41. I think. So the difference between 2 numbers is 66. There are 4 people, some of whom always tell the truth. 1 2 3 4. 1 2 3 4. Let's say lie or truth. For example, if let's assume the first person tells the truth, then odd number us always tell the truth. So 1 odd number of us, even number of us, prime number of us, square number of us. So odd number of us. So truth could tell the truth is 1. Okay. So if the first person tells the truth, then 1 or 3 should tell the truth. So first one, truth, odd number. Then even number cannot be 1 or 3. So if it should be 3, because 1 is not prime number. But prime number and square number, this cannot be together. So this is not possible. I think we can find like this. Let's say if the number of people, like 1 person or 2 or 3 or 4, let's say like this. If 1 person is telling the truth, then let's say this A, B, C, D. A is telling the truth, odd number, and it is not prime number, and square number, D. So this doesn't make sense because this is not the 1 person. So if there are 2 people who tell the truth, then odd number is not, even number, yeah, it is the true. Prime number is true, square number, no, it's not. So maybe 2 can be the number, and 3, let's say odd number can be the truth. Even, no, prime number, yes, square number, no. So this cannot be truth. 4, not odd, even number, and not prime number, square number. So, but it is not 4, so this cannot be. So maybe 2 people are telling the truth. Number 15, diagonal shows 6 congruent equilateral triangle. 1 2 3 4 5 6. Okay, side length 2, parallelogram, length of PR from here to there. Let's see how we can make. So this is 2 and this is 6. Again, this we need to know about this special case of right triangle, which has the angle of 30. So here 60, here 30. So when this is 2, this should be 1, this should be square root of 3. So here now we have right triangle with this, and we can use Pythagorean theorem. So this leg has the length of 7, and this leg length of the square root of 3. So square root of 7 plus square root of 3, 52. So this is the square root of 52, which is 2 square root of 13. Two number x and y have a product equal to their sum. X, y equal to their sum. X in terms of y. Okay, then we need to isolate x on one side and separate the x from the other expressions. So y over y minus 1. 0.8 plus 0.07, but all recurrence. 0.8 is 0.888888. 0.9 is 0.077777. So this is a little bit confusing. 0.8888. 0.07777, let's say. So there is no end, but let's assume if we have the last digit of this recurrence the decimal, then it could be 5. It should be 5. And 6. And 6. And 9. But as I told you, there is no end. It's endless. So this can be 0.0 and 0.9666666. So let's say like this. But this was just like easy guess. But if we need to solve this very properly, we can convert this to the fraction. When we have this recurrence number only one digit, we have 9 on the denominator. So this is 8 over 9. Plus, this has one recurrence number and one non-recurrence number. So 9, 0. This comes from the number of recurrence number, and this one comes from number of non-recurrence number. So this, the denominator is 90. And this one, 7 minus, actually we need to, here is like 007 minus 00, like this. So whole number, and we need to subtract the non-recurrence numbers, but here everything is 0, so we don't need to do that. So this is 7. So 90, 80. So this is 90, 87. So which means 90, yeah, we need to subtract something, becomes 87. So let's say this one, 87 minus 8 cannot be 87. This is not recurrence. 95 minus 9 is 86. 96 minus 9 becomes 87. That's why this is 98 minus 9 becomes 89. So this is not the answer. And the number 18, two numbers, x plus y, 2 over 3, xy, 2 over 3. So when we do this, the cross product, 3x becomes 2y. Let's say 2y over 3 is x. So when we put here, 2y over 3 plus y is 5y over 3 becomes 2 over 3. So that is y equals 2 over 5. So now x becomes 3 over 2 times 5 over 2, 2 over 5, so 4 over 15. So y minus y, x minus y, 4 over 15 minus 6 over 15, so negative 2 over 15. Largest value, let's say 12 over 7, which is larger than 12 over 6, so this is not the answer. And here, let's say 60, 15, 12, plus 10. So 37. So this is 60, 35. So again, and here, let's say we can compare, because already two of these are the same, so we can compare only this and this. 56, 15. So 56, 16. So actually, C is larger than D. So now we have the same number. 1 over, it's not very helpful. Okay, so we need to compare between C and E. Let's do that. Yeah, let's take it out 1 over 6 because already they are like the same amount of number. So we can compare only two of these. Let's say 29 over 20. And this one is quite complex. I think it must be easier way to compare. Let me compare with D and E just to be safe side. So this and this is same, and this 90 over 19. I mean 19 over 90. This one 18. Oh, this is larger. This is larger, but 1 over 90 amount larger. So this one, let's say how much is larger. So this one was 15. This was 14. Sorry, this was smaller. So when we compare this and this, actually E is larger. So E is the largest one. Number 20. Equator triangle, side length 1. Total shaded area, half the area of the larger triangle. Oh, so 3. This 3 has, okay. So this is 1, 1, 1. And let's say this is S. And this has 3S. This is the amount of the, the size area. So larger equilateral triangle is the area is 6S. So this and this, the larger one is 6S. So in terms of the ratio of the area is 1 to 6. So the ratio of the length should be 1 to square root to 6. So it should be square root to 6. Diagram shows a right angle triangle PQR, point S midpoint, QPR, tangent QPR, 3 over 2. Okay, here, 3 over 2. So let's say here, from P, this is opposite, and this is adjacent. So tangent is TOA, opposite over adjacent. Let's call this X. Then the opposite is 2X, and we don't know what this is. So 3, 4X. So this one is 4x over 3. What is the value of sine QPS? QPS. So with here. So we need to know what this is. Okay, then now we know everything. So now we're talking about just the ratio of the sides. So we don't need to go with this, the fractional expression. So here, let's say I'll call this 4x and call this 3x. This is a new expression. Then SP could be 5x. So from P, sine P with this smaller right triangle could be 5x and 3x, so 3/5. 4 of the following 60-digit integers are always divisible by 7. Okay. Not necessarily multiple of 7. Okay. So divisible by 7. So we don't, they got the list of the values of the digits P and Q. So we don't know what is P and Q. And it is not important. So I will express them like with all these values. So P times 0, 1, 2, 3, 4, 5. And Q 4, Q 3, P, Q, Q. So from here, if I factor of them, then 10 to the power of 3, and P 10 to the power of 2, Q 10, Q. And here same. So when I factor them, 10 to the power of 1, 3 plus 1, and P, Q, Q. So because it has regardless of the values of the digits P and Q, so we need to be independent from P and Q. So if this is divisible by 7, then this one always should be divisible by 7. So that one is 1, 0, 0, 1. So let's say 7. Okay, this is divisible by 7. So A always divisible by 7. And let's go for the B. PQ, PQ, PQ. So for example, here, when I combine them together, 10 to the power of 4 and 10P plus a Q plus 10 to the power of the 10 squared, 10P plus Q, 10P plus Q. So now this one also 10 and 10P plus Q. This also need to be independent. So 1, 0, 1, 0, 1. Let's check whether we can divide it by 7. 31, 4, 28, 30, 4, 28. Now we can divide by. So A and B both divisible by 7. Let's go for C. QP, QP, QP. Actually, this is the same because it's repeats again. So we will have 10 to the power of 4 plus 10 to the power of 2 plus 1. So no need to think about it. And this one, this is P. And 1, 1, 1, 1, 1, 1. So if this is divisible by 7, then it will be divisible by 7. Before we go there, we can try this one. So this one, P plus Q, 0, 1, 2, 3. So this is 10 to the power of 3 plus 1. No, it doesn't make sense. 10 to the power, what is that? 10, 5, 4, 3. Okay, so this will be 10 to the power of 3p plus q and 10 to the power of squared 10 plus 1. So 1, 1, 1. Did we check 1, 1, 1? Let's check once more. Oh, this is not divisible by 7. But just to be safe side, let's check this 6 ones, whether it's divisible by 7. 1, 1, 1, 1, 1, 1. 41, 61, 51. I think this will not. 41, 61, 51. Oh, okay. This is divisible. So the answer is number E. And let's go for number 23. Triangle. Sum of all the values of which triangle is isosceles. Okay, so we don't know what are same. So we can see this and this is same. Let's say 3n plus 3 becomes 2n plus 12. So n becomes 9. So this can be the answer. No. Because now the number, because of this, I need to doubt myself. The answer need to be checked. So when n equals 9, this is 81, 90, 30, 30. Because the triangle always have the property, when we add any of the two sides, it should be larger than the other side. Whatever it is, it should be larger than other side. But 30 plus 30 is not larger than 90. So 9 cannot be answer. So n squared plus n becomes 2n plus 12. N squared minus n minus 12 equals 0. So for 3, n can be 4 or negative 3. Negative 3 cannot be answer because it makes this negative. So length cannot be negative. Let's check 4. So when it is 4, 20, 20, 15. So this can be the answer. So at this moment we have 4. And let's check when they are same, the case. N squared minus 2n minus 3 equals 0. So n can be 3, but n cannot be negative 1 because this will be 0. So n need to be 3. So this is 12. This is 12. This is 18. So this is possible. So the answer is 7. 24. 5, 6, 5, 5 divided by 2, this is positive integer n, remainder is 11. So 5, 6, 5, 5, we divide by something, the remainder is 11. Which means when we express the number 56, 55, like the dividend and divisor, let's say P and Q, N and Q, remainder 11. And when we subtract it, 56, 44, so the divisor is the factor of 5,644. And this one, 5879 also, and let's say P plus 14. So 5865 is a multiple of the divisor n. So n is the factor of this and factor of this. So let's find the factors, common factors of them. 5, 6, 4, 4, 5, 8, 6, 5. What can be, let's not do it like this. So 5, 6, 4, 4, 4, 1, 4, 1, 1. Can we find something from here? It's difficult. Let's find from here. 5, 8, 6, 5, 5, 1, 1, 7, 3. So 1, 4, 1, 1 and 1, 1, 7, 3 should have something. Actually, this can be divided by 3 because 1, 1, 7, 3, when we add them together, it is 12. So 3, 27, 1. This one, oh, I don't know what can be further. Maybe sum of the digit of n. So the numbers are not so large, so it should be found. Six was my calculation. 79, 5, 5, 5, 6, 5, 5, 4, 4. What? I don't know. Sum of the digits of n. So we don't. Let's say what can be 1411 and 391. 391. Can we find any? Let's say, for example, 17. 391, 17, 2, 34, 51, 3. Okay, this is 17 times 23. Maybe this may have 17 or 23. Let's say 17. Okay, so this is 17 times 83. So both of them has 17, which is a common factor, which is the sum of the digit is 8. So when one digit is easy, but like this 2 digit, we need to go through it. And 25. 3 touching semicircles with radius 1 inside the equilateral triangle. Semicircles also touches. Okay. Length of each side of a equilateral triangle. So semicircle has the radius of 1. So this one is 1, 1. Yeah, when we connect them together, this has 2, 2, 2. This is 60. And this can be because this is 60 and this should be, this is my guess. How can I, but I think that is the right angle, but how can I know that is right angle? Let's see, let's figure it out. No, it is not right. It cannot be right angle because this is 2. This is larger than 1, so it's not the right angle. Size of roots triangle. Let me put it like this. This is right. Okay. So here 1, which means this is 30. This is a 30. That is, and this is square root 3. And this is 60. And this is 30 because all looks the same. So that is 9. Then this is 30. Okay, I was confused. This can be 2 because this is not the hypotenuse. So this is 30. So which means here 2 over square root 3. And this one like 4 over square root 3. This comes from the ratio. So this is 4 over square root 3. This is 2 over square root 3. So altogether 6 over square root 3. So rationalize it. 6 square root 3 over 3. So 2 square root over 3. That's it.